The first parametric test that we will consider is the t-test. We have to make a distinction between the independent samples t-test and the paired samples t-test. The independent samples t-test compares the means obtained by two unrelated groups on the same continuous dependent variable. For instance, if you wanted to test whether there is a significant difference in test anxiety between two unrelated groups of students, such as undergraduates and postgraduates, you can measure anxiety in both groups and then conduct an independent samples t-test to determine whether the obtained sample means are different from each other. A paired samples t-test, also called a dependent t-test, is used to determine whether the mean of a dependent variable, for instance vocabulary level, is different in two related groups. In a paired samples t-test, each participant is measured twice on the dependent variable, resulting in pairs of observations. For instance, you might want to assess the mean vocabulary level in a group of grade 1 learners before and after 4 weeks of extensive reading. You chose to follow a repeated measures design, where you measured the dependent variable vocabulary in exactly the same manner before and after the intervention. You can then conduct a paired samples t-test to determine whether the group mean obtained before the intervention is different from the group mean obtained after the intervention. Note, though, that a repeated measures design like the one described does not provide solid evidence for the effectiveness of the intervention, as vocabulary growth could be the result of another factor. In other words, you would ideally include a control group in this type of study. If you want to read more about the assumptions that have to be met in order to do a t-test, you can click on the link that I provided here. When you report the results of your t-test, you have to include the t-statistic and the p-value. At the bottom of this slide, I've provided one example of how you can report the results of your t-test. To understand the results of an inferential test like the t-test, I have to now get a bit technical, so bear with me. In hypothesis testing, when groups are compared, we first propose a null hypothesis, which can be written as a statement. The null hypothesis, written as H0, typically states, no difference exists between the groups. We then propose an alternative hypothesis, called H1. H1 can be formulated as, the two groups are different from each other. We can accept H1 if there is good evidence against the null hypothesis. An inferential statistical test, such as a t-test, will produce a significance probability, a p-value, and a test statistic. The p-value indicates the likelihood that the observed test statistic belongs to the distribution described by the null hypothesis for the test. In other words, a p-value of 0.5 suggests that there is a 50% probability, in other words, a 1 in 2 chance, that the observation fits the null hypothesis. So there is a 50% chance that the groups are not different from each other. A 1 in 2 chance does not provide solid enough evidence for us to reject the null hypothesis. And so we will have to accept that the groups are not different from each other, even if there is a difference when one looks at the descriptive statistics. A p-value of 0.05, on the other hand, suggests that there is a 5% probability, only a 1 in 20 chance, that the null hypothesis is correct. And in this case, we can safely adopt the alternative hypothesis that the groups are different from each other. A p-value of 0.05 is usually taken as the cutoff probability. P-values of 0.05 or smaller provide evidence against the null hypothesis, whereas values greater than 0.05 do not. If you obtain a p-value of 0.05 or less, you can thus say that there is a significant difference between groups. On this slide, you can see the output that is generated by a statistical software program, in this case SPSS, when you run a t-test. As you can see, When conducting the test, you can ask the program to provide you with both descriptive and inferential statistics. The top table, labeled Group Statistics, includes the variables that are being compared, namely English Peabody scores and Northern Sotho Peabody scores. The Peabody is a standardized test that measures vocabulary knowledge. The top table also indicates that two groups are being compared, namely Group 1 and Group 2. Finally, it gives the number of participants in each of the groups, as well as the means, the standard deviations, and the standard errors of the means obtained by each group. The bottom table, labeled Independent Samples t-test, provides the result of the assumption test as well as the result of the t-test. In this case, the assumption test is called Levene's test for equality of variances. The test statistic of Levene's test is F, and in the column labeled Significance, it can be seen that Levene's test did not produce a significant result for either of the dependent variables. Remember that this is good, as a significant result here would mean that the data does not meet the assumption that the variance between the groups is equal. In the rest of the table, the t-statistic is given, and in the column Significance two-tailed, it appears that there was a significant difference between the groups on the English Peabody, as P is smaller than 0.05, but there was no significant difference between the groups on the Northern Sotho Peabody, as P equals 0.832, which is bigger than 0.05. What could explain this result? If you guessed that Group 1 consists of Northern Sotho-speaking learners that attend a school where the language of learning and teaching is English, whereas Group 2 consists of Northern Sotho-speaking learners that attend a school where the language of learning and teaching is Northern Sotho, you guessed correctly. In addition to reporting the results from your t-test, we are increasingly expected to report effect sizes. A t-test only tells you whether observed mean differences between two groups are real. In other words, the difference did not occur by chance. It does not tell you the size of the difference. Providing an effect size in your results helps to overcome this limitation. You can report Cohen's d as an indication of the size of an effect.